To understand the megastorms of the year 2075, we have to start with the foundation, Earth itself. Hurricanes, typhoons, and cyclones are not random events. They are heat engines powered by the ocean. For decades, scientists have shown that as humans release greenhouse gases into the atmosphere, the majority of that extra heat is absorbed by the seas. In fact, more than 90% of global warming's excess energy ends up in the oceans. This is critical because warm water is the single most important ingredient for storm formation. It fuels the towering thunderstorms that spin up into cyclones. The warming ocean is not a uniform process. Some regions, like the Western Pacific and the Gulf of Mexico, are heating at faster rates than others. These hotspots are especially concerning because they already host some of the strongest tropical storms on record. When ocean surface temperatures climb just a degree or two higher than historical averages, the difference in storm potential is enormous. But temperature alone is not the only driver. A warmer atmosphere holds more moisture. For roughly every 1 degree Celsius of warming, air can carry about 7% more water vapor. This means storms of the future will have access to a much larger supply of moisture to condense into rain. Scientists project that by mid-century, rainfall rates near the core of the most powerful storms could be 10 to 15% higher than today. The result would be flooding events of a scale that current infrastructure is simply not designed to withstand. Another crucial factor is the phenomenon known as rapid intensification. This occurs when a storm's wind speeds increase dramatically in a very short period of time, sometimes by 50 miles per hour or more within just 24 hours. While such explosive growth has been relatively rare in the past, it is becoming more common as the oceans warm and the atmosphere becomes richer in moisture. By 2075, extreme rapid intensification is expected to be a defining feature of many storms that do form, making them harder to prepare for and far more dangerous. The physics behind this is simple. More heat and more water vapor mean more available energy. The climate system is not inventing new rules. It is simply working with a new set of conditions. And in this new environment, the storms are evolving into something fundamentally different. What were once rare monsters of wind and water could become the new normal by the middle of this century. By the year 2075, we may find ourselves in a strange paradox. Climate models suggest that the total number of tropical cyclones worldwide could actually decline by as much as 10 to 30%. At first glance, that might sound like good news: fewer storms, fewer disasters, right? But in reality, this quieter atmosphere sets the stage for something far more dangerous. The storms that do manage to form will not be ordinary. They will have to fight through tougher atmospheric conditions, and only the strongest will survive that gauntlet. But once they do, they will draw from oceans that are hotter than at any time in recorded history. That means the ones that reach maturity will have the potential to grow into superstorms of nearly unimaginable size and power. In this scenario, the familiar Saffir-Simpson hurricane scale may no longer be enough. Right now, Category 5 marks the peak, with sustained winds over 157 miles per hour. But by 2075, scientists believe there may be storms so intense that a new hypothetical Category 6 would be necessary, defined by winds above 192 miles per hour or more than 300 kilometers per hour. Several storms in recent decades have already brushed close to this threshold. In the future, it could become a terrifying reality. And wind is only one part of the equation. The destructive potential of a storm does not rise in a straight line. A storm with winds just 10% stronger can release exponentially more energy, shattering buildings, shredding power grids, and toppling infrastructure that once seemed indestructible. A single megastorm could wipe out decades of development in a matter of hours. Storm surge will add another layer of devastation. Rising seas, driven by thermal expansion and melting ice sheets, will amplify the push of water inland. By 2075, a superstorm striking a vulnerable coastline could send waves dozens of miles beyond the shore, inundating areas that have never before seen saltwater flooding. Entire neighborhoods, towns, and even cities could be erased from the map overnight. For those living inland, the threat will not disappear. With storms expanding in size, rainfall and winds will extend far beyond the coast. Mega storms could bring catastrophic flooding to river valleys, trigger deadly landslides in mountainous areas, and unleash tornado outbreaks as far as hundreds of miles from the ocean. In short, nowhere in the storm's vast footprint would be truly safe. In this hypothetical future, the idea of a hurricane season transforms into something else entirely. Long stretches of eerie calm will be shattered by the sudden arrival of one overwhelming storm. Storms so large and so violent that they define entire years or even decades of history. Coastal evacuation, once a temporary safety measure, could evolve into permanent migration, with millions forced to abandon the world's most vulnerable shorelines. This is the consequence of a hotter planet. Fewer storms overall, but those that do form will be monsters unlike anything humanity has ever faced. If storms by the year 2075 truly evolve into the megasystems we've imagined, then human survival will depend on adaptation at a scale we have never attempted before. In this hypothetical future, societies are forced to re-engineer the very way cities are built, how economies function, and even where populations live. Technology will be our first line of defense. Artificial intelligence, already a powerful tool in weather forecasting, could become the backbone of disaster prediction. By mid-century, advanced AI models may scan satellite, radar, and ocean data in real time, running millions of simulations within minutes. These systems could detect subtle atmospheric signals that hint at rapid intensification, giving communities a week or more of warning instead of just a few days. That extra time could mean the difference between orderly evacuation and total chaos. But forecasting alone will not keep people safe. Cities themselves will need to transform into resilient, storm-ready fortresses. Skyscrapers and homes may be constructed with aerodynamic curves to deflect extreme winds, anchored deep into bedrock to withstand surging seas. Entire districts might be elevated on platforms above projected flood levels, while surrounding wetlands and green belts are preserved or rebuilt to absorb excess rainfall. Urban planners talk about the rise of sponge cities, where permeable pavements, rooftop gardens, and vast reservoirs soak up water like a living shield. Critical infrastructure will also shift inland or underground. Power plants, data hubs, hospitals, and transportation links may be relocated far from coastlines. Energy grids will likely rely on decentralized systems, with solar, wind, and battery storage spread across regions to prevent a single failure from knocking out millions of homes. Some nations may even experiment with storm modification technologies, such as seeding clouds to disrupt intensification, though the ethics and risks of such interventions remain uncertain. For coastal communities that refuse or cannot afford to retreat, the adaptation may be even more drastic. Massive seawalls and surge barriers stretching for miles could rise to defend megacities like New York, Mumbai, or Manila. These structures would rival the scale of ancient wonders, engineered not for beauty but for survival against storms that push seawater farther inland than ever before. Yet not all adaptation will be physical. Social systems will have to evolve as well. Insurance industries may collapse under the weight of constant multi-billion-dollar disasters, forcing governments to establish new forms of disaster financing. Migration policies will need to handle climate refugees in the tens of millions, as entire regions slowly surrender to the advancing seas. And education systems may train future generations not just in mathematics and science, but in resilience, preparation, and survival strategies for life in a storm-dominated world. This imagined future is not inevitable, but it is one possible response to the terrifying scale of megastorms. Humanity has shown resilience before, but by 2075, resilience will no longer be optional. It will be the foundation of survival. As we imagine the year 2075, the forecast is both awe-inspiring and terrifying. The era of more frequent but smaller storms seems likely to give way to rarer, yet unimaginably powerful megastorms. These storms could span hundreds of miles, with winds exceeding any historical records and rainfall capable of reshaping entire regions. Coastal cities, floodplains, and even inland areas will feel their impact, permanently altering landscapes and economies. The choices humanity makes today will determine whether this scenario remains hypothetical or edges closer to reality. Reducing greenhouse gas emissions, transitioning to renewable energy, and enforcing smart urban planning can slow the warming that fuels these storms. Without decisive action, the storms of 2075 may no longer be confined to projections. They could define the lived reality of billions. Science and technology offer hope. By mid-century, AI-driven forecasting, climate-resilient infrastructure, and innovative engineering may allow communities to anticipate and survive storms that today would be catastrophic. Imagine early warning systems so precise that entire cities can evacuate safely days in advance, or skyscrapers built to withstand winds over 300 kilometers per hour. Yet even with these advances, the social and economic pressures of frequent megastorms will challenge governments, economies, and individuals alike. Education and global cooperation will also be key. People will need training in emergency preparedness, and nations will need agreements to assist those displaced by storm surges and floods. The concept of a storm-proof city may become commonplace, while migration plans and disaster funds could become part of national security strategies. The human ability to adapt will be tested like never before. Ultimately, the world of 2075 could be shaped less by the storms themselves and more by how humanity responds. While the destructive potential of these megastorms is staggering, so too is our capacity for innovation, planning, and resilience. This hypothetical future shows us both a warning and an opportunity to respect the power of nature, anticipate its extremes, and prepare wisely before it's too late. In the end, the megastorms of 2075 will not just challenge our buildings and infrastructure, they will challenge our imagination, our policies, and our willingness to act. The question is not if they will come, but whether we are ready when they do.